All right, my geometries. So this is your ginormous OST review for those taking the test in the December, which is the fall. I imagine this will be the same for the spring. You'll probably take it sometime in late April, early May. So that I don't have to make the video again. This is for you too. All right, think about that. How far in advance I'm thinking. There's 105 slides, by the way. So needless to say, I will not make one video. There will be a couple videos. The majority, the first 2/3, will be stuff we've done. So just it's directly from our notes slides. I will add some things as I think. And then the last third is new stuff, which I did also include a couple problems to go through just to kind of give you an idea of what to do. Okay? All right, so here we go. Topic covered in class as of Friday, 12/4/2020. And again, for those in the spring, whatever date it was. All right, so first idea is a midpoint. So again, a midpoint is the middle point of a segment, divides the segment into two congruent segments. Notice here on this picture, B is the midpoint. So because B is the midpoint of segment AC, that means that segment AB is congruent to segment BC. So midpoint creates two congruent segments on one segment. That means it bisects the segment. And then you notice that L is a line going through the midpoint. So we call L the segment bisector. Okay. And again, I'll just go like this throughout the notes. And you can slow down, speed up as fast as you want to. Types of angle pairs, complementary. When you see complementary angles, you should think sum of 90. When you think of supplementary angles, you should think of sum of 180. A linear pair is a special type of supplementary angles. They are two angles that form a straight line, or a straight angle in this case. So in this picture, angle ABD, this angle 1, and angle DBC, this angle 2, make a linear pair. Linear pair postulate says if two angles form a linear pair, then they are supplementary. So in this picture, the measure of angle ABD plus the measure of angle DBC will equal 180 degrees. Supplementary. Vertical angles are congruent, so when two lines intersect like these do, they create vertical angle pairs. Angle 1 and angle 3 are your V's to the left and right. They're congruent. They look acute. And angle 2 and angle 4 are going to be congruent. They're your V's opening up and down. They're obtuse. They're also going to be congruent. So again, vertical angles are congruent. Very useful in proofs. Angle bisector. So just like a segment bisector divides a segment into two congruent segments, an angle bisector divides an angle into two congruent angles. So in this picture, we have ray AY being the angle bisector of angle XAZ. So notice the congruent markings here, right? It splits the angle into two congruent angles, angle XAY, angle XAY, this angle, and angle YAZ, this angle. Angle bisector. Perpendicular lines are two lines that intersect to form right angles. This is the symbol. So in this picture here, we have line AD perpendicular to line CD. So all four of these angles, 1, 2, 3, 4 are right angles. Now, you can do one better by being a perpendicular bisector. So in this case, you have line EF being the perpendicular bisector of segment GH. So it splits GH into two congruent parts. Let's call that the midpoint M. And it also is perpendicular to the segment at M, so it creates right angles. Here are a couple constructions. So here's how you construct a perpendicular bisector. I'm going to highlight this right here, and especially this. When you draw the first two arcs, if you remember to get those, and it's down here, these two arcs, remember that this first arc, this distance, has to be greater than halfway across. You can't stop at the midpoint. You can't stop there. You have to go a little bit further. So that's the secret to the perpendicular bisector. The angle bisector is pretty simple. I think that you should be able to do this. You can use the same compass setting. You don't have to change the compass setting. So it says with the same compass setting. So remember that as you go through this. And again, on the OST, all you really have to do is talk about the steps. You don't have to really do the constructions. Coordinate plane time, we have the midpoint formula, so we don't care about the number line. I care about the coordinate plane. So this is the midpoint formula. So remember, this is the one that involves addition, because when you find the midpoint, all you're doing is you're finding the average of the x's and the average of the y's. And to do that, you add the x's and divide by 2. You add the y's and divide by 2. Again, addition, add. Okay. Recall in some of the problems, they would give you, say they gave you A and they gave you M. Remember that you can use the slope, rise over run, and you can count that, and then you can count that same slope to find the other endpoint. Remember doing that on the coordinate plane. That is a key type of problem you might see on the OST. Here is the distance formula. This formula is on the reference sheet, so I'll make a note of that. It's on the reference sheet. So use it. However, remember what we do is we would graph these 2 points, and then we would count the x, we would count the y. Remember, we would always make them positive because they're distances, and to find the distance, we would do what the x value or x distance was squared plus the y distance squared inside the square root. And remember, that is directly based off of Pythagorean theorem. So again, recall that. You can just use the formula. Just be careful of your positive signs and your negative signs. Don't get them confused. Remember that when you have a negative number and you square it, if you put it in parentheses, it'll turn positive. Okay, so that was all of chapter 1. All right, so here's chapter 3 on parallel lines. So this has been on the state test before, this idea of parallel versus skew and the idea of coplanar versus non-coplanar. So if you look at this picture here, let's use AE and BF. So AE is up and down, and so is BF, right? They're on this front plane. They're coplanar. They're never going to touch. You could also look at AE and BC. AE and BC would be an example of skew lines because they are as well not going to touch. One is going up and down. One is going, at you and away from you. They're not coplanar though. So again, the idea is that they don't intersect, right? Both cases they don't intersect. But parallel, it's coplanar. Skew lines are non-coplanar. Again, just means same direction. So parallel lines are running in the same direction. And there's the symbol for parallel, that double 11, or that 11 symbol. So in parallel lines, we are always talking about a transversal cutting parallel lines. So this third line is called the transversal. These arrows mean parallel. So here's what we're saying. L is parallel to M. We have 4 types of angle pairs. The first type is your same side interior angles. Remember, those are the only ones that are supplementary. So keep that alliteration of S, S, S. Same side supplementary. So 4 and 5 are supplementary. They add to 180. 3 and 6 are supplementary. Your alternate interior angles are going to be congruent. So in this case, we're still looking at these 4 angles, but now we're going on either side of your transversal. So 4 and 6 are congruent, and 3 and 5 are congruent. And again, remember, think obtuse and acute. 4 and 6 are your acute pair. 3 and 5 are your obtuse pair. When you're looking at these same side interior angles, 4 and 5 are an acute and an obtuse pair. They would be supplementary. They could add to 180. Your next type of angle are called corresponding angles. Corresponding are the only pair that have 4 pairs, and they are congruent. And again, you have to think of them in corresponding position. So where your transversal hits L and where it hits M, it creates 4 angles. So angle 1 is in the upper left. So is angle 5. It's in the upper left. So they're going to be congruent. And you so on with all the other corresponding angles. And then last but not least, your alternate exterior angles. The exterior is outside of the parallel lines. So 1, 2, 7, and 8. And again, alternate means on opposite sides of the transversal. So 1 and 7, 2 and 8. And again, think of obtuse versus acute. 1 and 7 are your obtuse angles. 2 and 8 are your acute angles. and they're congruent. So again, the only ones that are supplementary are your same side interior. Same side interior are supplementary. Everything else is congruent. Triangle angle sum, we should always remember that the sum of the measures of the angles are 180 degrees. Sum of your triangle is 180. Sometimes they put the proof on the test. So remember that you could draw this parallel line up here. So this line can be parallel to AC, and then you have alternate interior angles. So this angle and this angle are congruent. This angle and this angle are congruent. So these three angles, angle 1, 2, and 3, make this straight line. So they're supplementary, and because A and C are congruent to these ones, that forces these three angles to be supplementary or add up to 180 as well. Okay, so be aware of that. Here's your constructions for parallel lines. Parallel line construction is a toughie, so be aware of that. Here's your perpendicular to a point on the line. So again, in this picture here, P was on the line. So notice you still want those 2 points on either side equally distant from P. And then here's where you draw your one set of arcs, because you know that P is also on that perpendicular. For this one here, now your point is above the line C. So again, now you have to get your 2 points equally distant from R on the line, and then you draw your arcs down here. So I have it continued, I think, on the next slide. Yes. So there's that second point you need to then draw your perpendicular. Now we're going into slope and parallel and perpendicular lines. So again, remember, slope is rise over run. Here's how you count it. I don't think you'll see this on the state test, but remember, horizontal lines have a slope of 0. Vertical lines have undefined slope, so keep that in mind. Two important types of forms of lines. Slope-intercept form, you've always had this in your mind, y equals mx plus b. The new type we learned was point-slope form, looks like this. Remember that our goal is to put it in slope-intercept form, but typically in these problems, they give you a point. That point is xy, and then you'll also have a slope. And we're going to use parallel and perpendicular lines to find our slopes. So then here is our talk of parallel and perpendicular lines. So remember that parallel lines, the slopes are equal. So whatever the first slope is, you'll use that same slope. For perpendicular lines, remember we talk about the slopes being opposite reciprocals. So for instance, if one slope is 2/3, the other slope 2/3, the other slope is opposite negative and reciprocal 3/2. If one slope is negative 5/4, the other slope is now positive 4/5. So keep that in mind. That's how you use opposite reciprocals. And that gets us through chapter 3. So I'm going to stop this video now, and we'll pick up on chapter 4 talking about triangles.